Chapter 6 Applications of Vector Algebra. Scalar product and vector product. Definition. Given two vectors a vector equal to a1 I cap plus a2 j cap plus a3 k cap and b vector equal to b1 I cap plus b2 j cap plus b3 k cap. The scalar product or dot product is denoted by a vector dot b vector and is calculated by a vector dot b vector equal to a1 b1 plus a2 b2 plus a3 b3. That is, dot product of two vectors is nothing but sum of the product of the corresponding components. The vector product or cross product is denoted by a vector cross b vector and is calculated by a vector cross b vector equal to determinant I cap, j cap, k cap, a1, a2, a3, b1, b2, b3. Expanding this determinant, you can get the value of a vector cross b vector. Note, a vector dot b vector is a scalar. Dot product of two vectors is a scalar. Hence, this is called scalar product. Since we are using the symbol dot, the scalar product is also called dot product. A vector cross b vector. This is a vector. So, a cross b is a vector. Since we are using the symbol cross, this is also called cross product. Definition of dot product. A vector dot b vector equal to modulus of a vector modulus of b vector into cos theta. A vector cross b vector equal to modulus of a vector modulus of b vector sin theta into n cap. N cap is the unit vector perpendicular to both a vector and b vector. Taking modulus, we get modulus of a vector cross b vector equal to modulus of a vector modulus of b vector modulus of sin theta, and modulus of n cap is 1 since it is a unit vector. So, modulus of a cross b is modulus of a vector modulus of b vector into modulus of sin theta. An angle between two non-zero vectors a vector and b vector is found by the formula theta is equal to cos inverse of a vector dot b vector divided by modulus of a vector into modulus of b vector. From this, see the in the side kondu pona cos theta equal to a vector dot b vector divided by modulus of a vector modulus of b vector. So, theta equal to this cos inverse of a vector dot b vector divided by modulus of a vector into modulus of b vector. A vector and b vector are said to be parallel if the angle between them is 0 degree or pi. A vector and b vector are said to be perpendicular if the angle between them is pi by 2 or 3 pi by 2, 90 degree or 270 degree. Next, properties. Let a vector and b vector be any two non-zero vectors. Then, a vector dot b vector equal to 0 if and only if a vector and b vector are perpendicular to each other. So, if two vectors are perpendicular, a dot b equal to 0. Reverse or converse, if a dot b equal to 0, then a and b are perpendicular. Next, a vector cross b vector equal to 0 vector if and only if a vector and b vector are parallel to each other. A vector cross b vector equal to 0 vector, then a and b are parallel. Converse, if a and b are parallel, then a vector cross b vector is equal to 0 vector. If a vector, b vector, c vector are any three vectors and alpha is a scalar, then a vector dot b vector is equal to b vector dot a vector. Dot product is commutative. A dot b, b dot a ரெண்டுமே equal. A vector plus B vector dot C vector is equal to A vector dot C vector plus B vector dot C vector. A vector cross B vector is equal to minus of B vector cross A vector. Cross product is not commutative. A cross B equal to minus of B cross A. A vector plus B vector cross C vector equal to A vector cross C vector plus B vector cross C vector. If alpha is a scalar, then alpha A vector cross B vector is equal to alpha வெளியில் எடுத்தலாம் alpha into A vector cross B vector is equal to A vector cross alpha B vector. Definition for work done. If D vector is the displacement vector of a particle moved from a point to another point after applying a constant force F vector on the particle, then the work done by the force on the particle is work done is equal to F vector dot D vector. Force into displacement gives you work done. So work done is equal to F vector dot D vector. Next, torque or moment. If a force F vector is applied on a particle at a point with position vector R vector, then the torque or moment on the particle is given by torque is equal to R vector cross F vector. Torque is equal to R vector cross F vector. The torque or moment is also called the rotational force.